Welcome to Networks Professionals.
Welcome back to The Explainer. Look, if you've spent any time working in network engineering or system administration, you already know that managing network traffic can sometimes feel, well, a lot like trying to defuse a bomb while wearing oven mitts, right? It's delicate, it's high stakes, and literally one wrong move can bring an entire system down. I mean, we've all been there. It's a 2 a.m. maintenance window. You are fueled purely by stale coffee, and you feel that distinct cold stress sweat as you hit enter on a core router, just praying you didn't accidentally drop the entire management VLAN. Well, today, we're looking at a massive quality of life upgrade for network engineers that makes those late night heart attacks a thing of the past. We're going to explore the named ACL revolution based on some fantastic source material and uncover exactly how it's upgrading network management across the board. But before we get to the solution, we kind of have to talk about the problem. Have you ever had to delete an entire access list just to fix one single typo? If you've worked with traditional legacy access control lists, I know you are groaning right now. The shared frustration among IT professionals over this is a very real, very painful bond. Think about the grueling old way of doing things. You meticulously craft 20 lines of a critical security policy. You deploy it, only to realize you mistyped a subnet mask on line 5. With the legacy methods, you couldn't just reach in and fix line 5. No way. You had to copy your config into Notepad, fix the typo there, delete the live ACLs from the router, paste the new one back in, and literally hold your breath, praying the SSH session doesn't drop in the 3 seconds your firewall is completely open. It was exhausting, so prone to massive human error, and just incredibly stressful during an active deployment. Okay, let's dive into this. Because thankfully, the source material we're diving into today highlights exactly how we move past that dark age, pointing out that named access control lists offer a massively improved alternative to traditional numbered ACLs. Now, this isn't just some minor patch from vendors or a slight software tweak. It's an absolutely fundamental architectural shift in how we approach network security. It is a modern, painless solution that streamlines network management by taking the focus off of arbitrary, rigid constraints and putting the power back into actual, readable functionality. It allows you to maintain continuous security without risking a total network blackout just to fix a minor administrative typo. Section 1. The Named ACL Revolution. Leaving arbitrary numbers behind. And this brilliantly illustrates the extreme contrast between the old way of doing things and the new way. When dealing with traditional numbered ACLs, you're stuck with arbitrary numbers. You're entirely restricted to ranges, often running completely out of available numbers in the standard 1 to 99 range if you've got a complex enterprise network. And as we discussed, they require ripping out the entire access control list to fix a single line. On the modern side, named ACLs utilize descriptive, human-readable names, and crucially, they allow you to modify individual line entries on the fly. The immense technical debt and pain of the old way is entirely replaced by the precision and ease of the new way. You're going from managing this rigid, monolithic block of code that is frankly terrified of changes to a flexible, descriptive, and highly manageable set of rules. Section 2. 3 massive advantages or the superpowers of named ACLs. Our source material breaks down these specific superhero-like powers granted to system administrators into 3 key functional upgrades. Number 1 is micro-editing. Number 2, sequence numbers. And number 3 is meaningful identification. This specific combination is essentially the holy grail for network administrators. It's not just about making your script look pretty, right? These 3 elements work together to completely streamline how you maintain your network access policies, dramatically reducing downtime and significantly mitigating human error during live midday deployments. Let's look at the technical depth of each of these individually to really understand what they bring to your workflow. First up, micro-editing. The definition is beautifully simple: the ability to delete or modify individual line entries without having to delete the entire access control list. This is the absolute ultimate cure for that notepad copy and paste nightmare we mentioned at the start of this explainer. Imagine an auditor walks into your office and tells you that a specific, highly privileged legacy server needs its outside access revoked immediately due to a newly discovered vulnerability. With micro-editing, you don't have to rewrite the security policy for the entire server floor and risk a brief outage. You simply execute a surgical strike. You drop into the ACL, target that specific server's IP address, remove it, and you're done. The rest of the traffic flows perfectly without a single dropped packet or a single disrupted VoIP call on the network. The second massive advantage is sequence numbers. The source points out these sequence numbers, 10, 20, 30. Unlike the old system where rules were just stacked on top of each other sequentially in a rigid block, named ACL rules default to increments of 10. Why does the standard industry practice matter? Because by spacing them out in tens, you are giving your future self the ultimate gift, breathing room. Let's say you've got a general permit rule at sequence 20, but suddenly you realize you need to squeeze a highly specific deny rule in before that permit rule hits. With legacy lists, you were totally out of luck. But here, you can effortlessly insert that new deny statement as Rule 15. You do not have to rewrite the document. The sequence numbers give you built-in architectural space to expand, adapt, and weave your policies together organically. The third superpower is meaningful identification, things like block guest Wi-Fi or permit management VPN. Let's be honest, in the past, forcing the new guy to memorize that lists 100 to 199 are for extended routing while standard routing is 1 through 99, that basically felt like workplace hazing. It was essentially memorizing arbitrary code just to read a basic routing table. Now you can actually name your ACLs for exactly what they do. This meaningful identification completely eliminates the need to cross-reference spreadsheets or deeply buried documentation wikis just to figure out what a rule is supposed to be doing at 3 a.m. It's right there in plain, descriptive English, which dramatically speeds up troubleshooting when an incident response is actively underway. Section 3. Basic configuration in action. Seeing it on the screen. Let's move to the configuration process and see how this builds logically. Setting this up is actually a very straightforward 3-step process. Step 1. You define the named ACLs inside your global configuration mode. Step 2. Doing this immediately drops you into a specific submode for that exact list, and this is actually a massive safety feature. In legacy systems, doing global config changes ran the risk of accidentally applying a rule to the wrong interface if you weren't perfectly organized. This submode acts as a safety sandbox. And finally, step 3. Once you are safely inside that submode sandbox, you enter your specific permit and deny statements. It's a clean, nested structure that keeps you focused entirely on the exact security policy you are actively building. Now, what's really interesting about this slide is when we apply this process to real-world Cisco iOS syntax, you can see the logic instantly. Notice the first line where we're in global config mode, and we create the extended named list using that meaningful identification, block_guest_Wi-Fi. Then the prompt physically changes, dropping us into that protected submode. From there, you clearly see the sequence numbers in action, 10 and 20. This is exactly where the micro-editing happens. If you later decide that Rule 10 is slightly wrong, you can just address line 10 specifically without ever touching line 20. Also, any seasoned network engineer is going to immediately spot the logic here. We explicitly deny a specific host on port 80 at sequence 10 and then widely permit everything else at sequence 20. This perfectly manages the invisible implicit deny at the end of every ACL, ensuring legitimate traffic keeps flowing while our target is blocked. It's clean, targeted, and vastly more efficient. Section 4, supported modern environments. Where can you use this?
So the crucial point is that this isn't some niche feature locked to a single piece of hardware or an expensive proprietary license. As the source material confirms, named ACLs are fully supported across the board on modern enterprise systems. We're talking about Cisco iOS and iOS XE, Infoblox, Grid Manager, Juniper, Palo Alto, and various other firewall systems. In the reality of modern network engineering, you are rarely working with just one brand anymore. Multi-vendor environments are the absolute standard. And while the specific CLI commands might require a quick search when jumping from a Cisco core switch to a Palo Alto Edge firewall, the architectural logic of named lists, submodes, and sequence numbers translate to universally. It really is a standardized approach to network management.
Which brings us to our final thought directly from the source material. Knowing that these features are standardized across the board to save you from the headaches and risks of traditional numbered lists, the real question isn't whether you should use them, but rather, how much technical debt are you currently holding onto by keeping your legacy numbered lists alive? Is it time to finally audit your core switches, routers, and firewalls? Grab the exact syntax for your specific vendors and bring your access policies into the modern era. Thanks for joining me on this explainer, and happy configuring.
Thanks for watching.